Welcome to the deep dive. Today we're plunging into Spark Streaming. It's this really amazing tool for making sense of something called unbounded data.
That's right.
Our mission really is to unpack how insights get extracted, continuously from this constant flow of information.
It's a different way of thinking about data.
Exactly. So let's explore this idea. What actually happens when the data you need isn't, say, a neat file or a batch that arrives predictably, but instead it's like an endless incoming stream. Think maybe water from a tap that's just always on.
That's a good analogy.
Yeah, so this deep dive looks at how Spark Streaming handles exactly that, how it turns this relentless flow into, well, actionable knowledge right now.
And understanding that term unbounded data is key first, I think.
Right. What exactly is it?
Well, picture information that it never stops arriving. Think about real-time sensor readings from maybe thousands of machines in a factory.
Okay.
Or the constant flood of clicks and searches happening every single second on a big shopping website.
Constantly flowing in.
Precisely. It's totally different from traditional data sets, the ones with a clear start and a clear end.
Finite data.
Finite data, exactly. So the challenge isn't just processing volume, it's analyzing something that's always coming, always changing, without ever really being finished.
That sounds incredibly difficult to keep up with. So how does Spark Streaming actually, manage this? What's its core approach?
Well, that's the clever part, the material highlights. Spark Streaming isn't designed to wait for a batch to finish. Its whole principle is built around continuously listening for new data points.
Always listening.
Always listening. It sees each new piece of input, like a new sensor reading or click essentially, as a new row to consider.
Okay, a new row.
And these new rows immediately update what Spark calls its internal result table. So think of it like a live, always current view of your query's results. The insights are constantly refreshing.
A constantly updating result table. That's interesting, but wouldn't that be really inefficient? Constantly updating everything with these huge streams?
That's a really important point. And that's where the concept of incremental updates comes in. It's crucial.
Incremental.
Yeah, instead of recalculating everything from scratch every time a new bit of data arrives, Spark is smarter. It focuses only on the new information. So when what's called a trigger fires, and you can set that maybe every few seconds or after a certain amount of data comes in, Spark just looks at the fresh inputs.
Right.
And then it writes only the updated results, the changes to your storage. So you're not wasting cycles redoing work. It keeps things flowing smoothly.
Okay, that makes sense. And the research we looked at had some pretty concrete examples. Could you maybe walk us through one or two?
Absolutely. For instance, you can set it up really granularly, like using max files trigger 1.
Okay, one file at a time.
Exactly. Process data literally as soon as a single new file appears. That's super important for things needing near instant response, like, say, fraud detection. And it handles real-time queries easily, like counting how many times a specific action happens, maybe a button click on a site. You use something simple like group B action.count.
And you get that count instantly.
Pretty much instantly, yeah. Not hours later after some batch process finishes. The power is in that immediacy.
So once Spark has done this processing, derived these fresh insights, how do you actually get those results out? How flexible is it there?
Yeah, the output is just as critical. The sources detail 3 main output modes.
Okay.
There's append mode, which just adds the new results, good for logs, maybe.
Right.
Then complete mode, that outputs the entire updated table every time. Think dashboards needing a full snapshot.
Okay, the whole picture.
The whole picture, refreshed. And then there's update mode, which only sends the rows that actually changed since the last trigger, often the most efficient.
Just the changes.
Just the changes. And of course, for really big jobs, performance tuning matters. The research mentioned things like setting spark.sql.shuffle.partitions.
Shuffle partitions. What does that do?
It basically controls how Spark breaks up and distributes the work across its computing resources. Getting that right helps avoid bottlenecks and keeps everything running fast, even with massive data loads.
Got it. So pulling this all together, what does this mean for you listening in? It really means that real-time decision-making is becoming much more accessible. Spark Streaming lets you turn these potentially overwhelming data streams into clear, up-to-the-minute intelligence.
Which is huge.
Yeah, incredibly valuable for everything from cybersecurity, spotting anomalies, to monitoring industrial equipment, or even just reacting to customer behavior literally as it happens.
That real-time reaction capability is key.
Definitely. So to sum up our dive today, Spark streaming provides this powerful way to analyze continuous data streams, giving you an always current picture, moving beyond old-school batch processing.
And maybe a final thought to leave you with. As our world keeps generating more and more of this unbounded data from smart homes, wearables, connected cars, you name it.
It's everywhere.
It really is. So consider how this ability to process endless streams in real time might reshape things. What new possibilities, or maybe even what new challenges or questions, does this constant flow of information raise for the future? How we learn, how we react, how we innovate?